Today what we're going to be doing is working with more inverse trig functions, but then composing that with a different trig function. So yesterday you noticed that these compositions down here, it was either tangent of the inverse tangent or inverse tangent of the tangent. It was always the same function that was being composed with the inverse, where now we're going to have a trig function composed with an inverse of a different trig function. And we've done stuff like this before, we just didn't call it the inverse trig functions. Right here, if I'm asking you for the tangent of the arc cosine of 1/3, what this is really telling us is that if cosine of theta is 1/3, what is tangent of theta? And we did that before, back in sections 4.3 and 4.4, where I said, okay, cosine is this, find tangent, or find all 6 trig functions. So we're doing that same thing here. The only issue is we have to, again, remember our quadrants. So if the inverse cosine of positive 1/3, that means we are in quadrant number 1, so tangent will be positive. So we'll draw our right triangle, and there's theta. Cosine is the adjacent over hypotenuse, so now we have to calculate the opposite side. So 1 squared plus x squared equals 3 squared. So we have x squared is equal to 8. And then we square root both sides, x equals the square root of 8 can be broken up into square root of 4 times square root of 2, so that's going to be positive 2 times the square root of 2. So that is going to be our opposite side here, 2 times the square root of 2. So that means our tangent is the opposite, 2 times the square root of 2, over the adjacent 1, which is just 2 times the square root of 2. So like I said, we've done this before. It's just written a little bit differently now. Now in letter B, it's the secant of the arctangent of -3/5. So again, the way we think about that is if tangent is -3/5, what is secant? Well, arctangent or inverse tangent is negative in quadrant 3. Sorry, not quadrant 3, quadrant 4. So we know our angle has to be in quadrant 4. I know tangent is negative in quadrant 2, but remember the restrictions on the inverse tangent is only in quadrants 1 or quadrants 2, or from negative pi over 2 to positive pi over 2. So then we're going to draw our triangle, and tangent is the opposite over adjacent. So then we'll do 3 squared plus 5 squared equals c squared. So we get 34 is equal to c squared. C is equal to square root of 34. And we can't simplify that. So now we can calculate the secant. Well, secant is the reciprocal or the flip of cosine. And cosine is adjacent over hypotenuse. So the secant is going to be the hypotenuse over the adjacent. So our answer is the square root of 34 over 5. Okay, so now we're going to take this idea, and we connected it to what we learned in sections 4.3 and 4.4, and now we're going to take it a step further and apply it to algebraic expressions. So notice in these problems, we have an x in all of them. So our answers are going to have an x in them. All right, so in example number 2, we're going to write an algebraic expression that is equivalent to the expression, the sine of the inverse cosine of x. So what this is telling us is that the cosine of some angle is x. Remember, we can really write it as x over 1, which is the adjacent over the hypotenuse. So if I draw my triangle here, the adjacent side is x, and the hypotenuse is 1. So I took care of this inside right there. Well, sine is the opposite over adjacent, so we need to figure out the opposite side. And we can do that using Pythagorean theorem. So x squared plus b squared equals 1 squared. Well, we subtract we subtract x squared from both sides, so b squared equals 1 minus x squared. And then when we square root both sides, we get b is equal to the square root of 1 minus x squared. So this side right here is the square root of 1 minus x squared. So now the sine of our angle is going to be the opposite side, the square root of 1 minus x squared over 1, which is just equal to the square root of 1 minus x squared. So yeah, these problems, like I said, are going to have x in our answer. Then letter B, the tangent of the inverse sine of x. So it's going to look somewhat similar to this. So if we have our triangle, this time sine is x. So the sine of theta is equal to x over 1, which is the opposite over hypotenuse. So our adjacent side here that we're trying to figure out, we're going to do x squared plus a squared equals 1 squared. And I think you could see that we're going to get the exact same thing here. We subtract x squared from both sides. And then when we square root both sides, we get a equals the square root of 1 minus x squared. So that would be our adjacent side, and the tangent is the opposite over adjacent. So the tangent of theta is the opposite side, x, over the square root of 1 minus x squared. Now we can't have that in the denominator. We can't have a radical. So we'd have to multiply the top and bottom by 1 minus x squared. We're not going to do anything to the numerator here because that's just going to get more complicated if we do that. So it's going to equal x times the square root of 1 minus x squared over 1 minus x squared. So rationalizing the denominator is something that will come back to us. Now, letter C, we have what's the cosecant of the arctangent of x over the square root of 7. So tangent, remember tangent is opposite over adjacent. So if we draw a triangle here, the opposite side is x, the adjacent side is the square root of 7. Cosecant is the opposite over hypotenuse, or sine flipped. So we need to find that hypotenuse. So x squared plus the square root of 7 squared equals c squared. Well, all we can do is square the square root of 7. So then we have x squared plus 7 equals c squared, and then when we square root both sides, c is equal to the square root of x squared plus 7. So that's what our hypotenuse is going to be. Square root of x squared plus 7. So the cosecant here is going to be the hypotenuse, the square root of x squared plus 7 over the opposite side, which is x. So again, it's the same process that we did above and what we were doing earlier in this chapter, but now we're just having variable expressions. Like all of our answers here have x in them. All right, now the last examples here, it says complete the equations. Arc sine of 2 over x equals arc cosine of what? So we're going to fill in the blank. And right here we have a restriction saying that the absolute value of x needs to be greater than 2. Well, the reason why that's true is because we know cosine is the adjacent, we know sine is the opposite over hypotenuse. Well, if our x value was not greater than 2, then that would be smaller than the opposite side, and we can't have that. So, must be true for triangle to exist. So what I want to do is look at this problem and translate it into the words that we know. So basically what this is saying is if sine is 2 over x, what is cosine? So again, what we were doing up here, we said, hey, if in letter A, if cosine was x, what is sine going to be? So again, if sine is 2 over x, we're going to draw our triangle again. And sine is the opposite over hypotenuse. We need to figure out what cosine is. So we'll do the Pythagorean theorem here and call this adjacent side A. So a squared plus 2 squared equals x squared. And we have to solve for a. So a squared equals x squared minus 4. A is equal to the square root of x squared minus 4. And because there's that subtraction sign, we can't take the square root of each of those separately. So then the cosine of theta is going to be the adjacent side, square root of x squared minus 4 over x. And we can't cancel anything out, so this would be our final answer. All right, then our last one, letter B, if the arc sine of the square root of 36 minus x squared over 6 equals arc cosine of what? And again, these restrictions are here so that the problem can take place. If x is bigger than 6, we then have a negative square root. If x is smaller than 0, then it actually will make the numerator bigger than the denominator, which can't happen in sine. So we're going to draw a triangle again. Arc sine, so that means that the opposite side is the square root of 36 minus x squared, and our hypotenuse is 6. We need to again find our adjacent side because we're asked about cosine. So a squared plus the square root of 36 minus x squared equals 6 squared. Well, the beautiful thing is that the square root that's in the opposite side and the square from the Pythagorean theorem are going to cancel. So we get a squared plus 36 minus x squared equals 36. Minus 36 from both sides, we get a squared minus x squared equals 0. And then when we add x to both sides, we get a squared equals x squared. Well, then we can square root both sides. And I know one of the reasons that makes these problems confusing is that instead of trying to solve for x, we're trying to solve for a. Or these problems up here, we're solving for a, solving for b. We're not trying to get x by itself in these problems. We're getting the problem in terms of x, where it's something equals an expression that has x in it. So our adjacent side is equal to x. So then that makes the cosine is the adjacent side, which we calculated was x, over the hypotenuse, which is 6. So these problems are really not that bad once you just remember what we did, like I said, in those previous chapters, and you're comfortable having x in your answer. We're not solving for x for these problems. So thanks for watching. Make sure to like the video and subscribe.